Hello friends, I'm starting today new lecture series. Let's be friends with the physics. So I'm starting with the class 11 physics NCERT, and I'm starting with motion in one dimension. Unit 1 and 2 are relatively easy, and maybe we'll discuss some other time. So today I would like to start with motion in one dimension. What is motion? When any object changes its position with respect to another object, we say that the object is in motion. You can see over here in the screen with respect to this tree, the bus is in motion. But is the tree itself stationary? No. Tree is stationary with respect to the present situation. But with respect to the, you can say tree is on the earth is revolving around its axis, earth is also moving around sun. So in itself, due to some other reference point of the space, tree itself is also moving. So motion is always relative with respect to some common reference point. You can say the things are in motion or they are in stationary, right? So for our study, when we are on the earth, when we are on the ground, with respect to that, at present, we can see the bus is in motion. You would like to study the motion. You have learned the basics in, I think, class 9. And today will lead you to the further advancements. So everything in the universe is in motion. We know our Earth is in motion. Our galaxy is also in motion, and that means everything is in motion. What is motion in straight line? When the change in position is only in one dimension. So here, it is also known as rectilinear motion. You can see the motion is only in one dimension. And the other thing we'll learn motion in 2 dimensions, projectile motion, we are going to learn in our next class. Why do we study this motion? We study not only for getting good grades in class 11, it is also that there are real life situations like you would like to calculate estimated time of travel when you want to travel between 2 cities, or when you want to calculate the distance. Suppose with certain speed you travel between 2 points and you would like to find out what was the distance that you can calculate. If you want to calculate speed, suppose you know the distance and you have measured the time to reach that distance, to cross that distance, then you can calculate the speed at which you have traveled. You can also calculate acceleration. You can calculate braking distance, reaction time. So all these concepts which you are going to learn in this chapter are going to be useful in your real life also. So these are the definitions: path length and displacement. Most probably you know it from your class 9 knowledge, but let's revise for those who have rather misplaced somewhere in their mind. The distance traveled by a particle in some time interval is called path length. You can see the dotted part over here is a path length, and it is always positive. But the change in position of an object in some time interval is called displacement. So what was initial position and what was final position? That only if you consider, then this change in position is called displacement. So displacement is nothing but the final position minus initial position. Displacement can be positive, negative, or zero. You consider one dimension to be positive dimension of displacement or movement, then of course the opposite is going to be the negative dimension. And when you again come back to the same position, you say the displacement is zero. So starting point and end point, if they are same, the displacement is considered to be zero. What is positive displacement? You can see this is a small animation created for your ready reference. So this is the B. So you can see the starting point was somewhere over on the right side of the screen over here. So this was starting point and this is end point. So the displacement is this, but the blue line makes the path length, which is a far more longer than the displacement. So it is positive displacement. This is another example where the displacement is negative. So consider to the previous positive direction. Now the B is moving backward. So final position, initial position are in such a fashion that compared to the previous case, this displacement is now negative, right? And this is zero displacement where you can see the starting point and end point are same, right? So now the concept of speed. So you divide the average speed is nothing but the path length divided by time taken. Please keep in mind path length, not displacement. So the speed is a scalar quantity. Here direction is not important, just how much is the distance covered and how much is time taken, that will give you the average speed. So here you can see the average speed is 200 divided by 20, that is 10 meters per second. While velocity is in a particular direction. So velocity is nothing but displacement divided by time taken. So velocity has a direction. It can be positive, negative, or even zero, and it's a vector quantity. So you can see over here, displacement is only 50 meters. The average velocity is going to be over here, which is only 2.5 and not the 10. So velocity is directed, velocity is in a particular direction, and it is displacement in a particular time. So concept of particle is what is important over here. So whenever you are learning a motion, you sometimes or most of the time we are not taking into consideration the shape of the object. The shape can be a bus, a car, a ball. It can be anything. So what do we observe over here? That can we not consider that object as a point? So in certain situations that is true. If the distance traveled is larger than the size of the object, and also if the body, the object is solid, where the motion of the whole body or motion of one particle is also going to be one and the same thing. So in that case, we'll consider the object of motion as a particle. So while studying motion, the object is treated as a particle, and physical size of the object is not considered. Of course, this is true in certain cases only. In certain cases where the particle itself or the object itself is having very huge size, there you have to consider the size of the object also. Now the frame of reference. So how can we know that the object is in rest or in motion? So you can see over here, let's consider the famous example given in NCERT class 11 book is, consider that a bag is there in the train. So look at the situation. So this fellow over here is having this bag. So the person which is traveling is considering this bag as a stationary. Once again, look at the video. You can see over here, this bag is stationary for the person who is traveling in the train. But for this fellow, the bag is in motion. Is it not? So the frame of reference is the point from which you are looking towards the motion. So if the frame of reference is the person who is looking from the train itself, then the bag is in stationary position. Once again. And if the person who is outside the train on the ground, he is observing the bag, then for that, the bag is in motion, right? So in short, a place and situation from where an observer takes his observation is called the frame of reference, right? So frame of reference is very, very important. We'll learn about inertial reference frame and all in our coming sections also. So now, to study the motion or to have equations and to solve examples, the very fundamental thing which you want to understand or which you would like to learn first is the position time graph. They are also known as XT graphs, right? So XT graphs are nothing but suppose I have noted down time and displacement on a table. So with certain time, suppose you can say 1, 2, 3, 4. You have displacement also say x1, x2, something like that, right? So I have table, I have numbers, I have observed time, I have observed displacement, and if I represent it on a graph in such a fashion that this is my time axis, x-axis is my time axis, and if I have a displacement or distance traveled, displacement is on x-axis, right? So suppose it is like this. So the displacement is constant with respect to time. At any time you measure, the displacement is same. What does it mean? That the displacement is not changing with time. Suppose at T1 displacement was x, and at T2 also displacement is x. So now if I want to find out velocity, what is my average velocity? It was nothing but x2 minus x1 divided by T2 minus T1. As x2 and x1 are same, x2 minus x1 is 0. and that's why you can say that this is a zero velocity situation. So from this graph, we can see that if the x versus t graph is horizontal, you can say that the motion is not taking place, or the displacement is zero. So, displacement is constant. Therefore, velocity is zero. Right, the object is not changing its position. Right, this is case one. Now, case two is, suppose you have a situation where the displacement is changing in this fashion. So you can see that displacement with respect to time is a straight line, where you can say initially at t1 the displacement was some x1, and then after t2 time the displacement has increased to x2. So here you can see the average velocity which you get over here is nothing but x2. So x2 minus x1 divided by t2 minus t1. So it is going to be a positive number, right? And as it is straight line, the x2 minus x1 divided by t2 minus t1 is nothing but the slope of the transmission line. Slope of the straight line. So it is going to remain constant. Therefore, this is the situation where you can say velocity is constant. And this is called uniform motion. When the velocity is constant, so at any different time interval, the displacement is also going to be same, right? So in a particular time interval, displacement is x unit, in the other time interval, it will be proportionate, so that the ratio remains same, or average velocity remains same. Such a motion is called uniform motion. The other situation is third is that you have a x versus t graph in a given manner, where the line is decreasing, the slope is negative. So here you can see that this is t1 and this is x1, and this is t2 and this is x2. So you can see the displacement has reduced with respect to time. What does this mean? That means the movement is in backward direction, or displacement is in reverse direction. So here the velocity which you are going to get is nothing but x2 minus x1 divided by t2 minus t1 is going to be a negative number. A negative number. So velocity is going to be, so this is a uniform motion, but it in opposite direction. So its motion is opposite or reverse direction. Of course, what is positive and what is negative direction is something, the convention which you have selected based on your study, right? And the fourth case is that suppose the x versus t graph is not a straight line, but it is a curve, something like this. So this is the situation where at different time interval, the displacement is different and you cannot comment on any particular pattern. Such a motion is called non-uniform motion. Right? So this was the initial part of the talk. Motion in straight line means the object is moving in only one dimension. We have seen what is path length. We have seen what is displacement. We have seen the concept of average speed, average velocity. We have seen what is concept of particle. We have seen what is the definition of motion. We've also seen the concept of velocity. And lastly, we had discussed about the concept of reference frame and then x versus t graph. So from x versus t graph, if I know the distance or displacement at different time intervals, I can plot it on a graph time on x-axis and on y-axis I take the displacement. Then I get a graph which tells me what type of motion it is, right? So whether it is a zero velocity motion, whether it is uniform motion, whether it is non-uniform motion. So that helps me in studying the motion of straight line in motion in one dimension in detail, right? So that's all in the first phase of this presentation. We'll study with about acceleration, instantaneous velocity, and other topics in my subsequent videos. Thank you.